Now I'm going to explain about star delta transformation and derivation for star delta to star and star to delta transformation. First about star connection and delta connection. What is meant by star connection? In a star connection, components are connected in such a way that in star connection, components are connected in such a way that one end of all resistors or components are connected to a common point. So in star connection, components are connected in such a way that one end of all elements, here usually three elements, so one end of all resistors, that may be inductor or capacitor also, so one end of all components are connected to a common point. Now by the arrangement of three components, three resistors, let us say this star network looks like a alphabet Y. Hence, this network is also called as Y network, alphabet Y network. So, by the arrangement of elements like this star network looks like a alphabet Y. Hence, this is also called Y network. Y network. Now, the equivalent of this star connection can be redrawn as T network. It can be redrawn as T network. That is a 4-terminal network. It becomes, which is shown in figure. So now see that here, if they're telling that the equivalent of this star, that means the star connection can be redrawn as a T network. That becomes a 4-terminal network. So which is shown as in figure. Now see that. And most of the electrical network constitutes this T-form network. Many electrical circuits have this T-form circuit. Now this star network and its equivalent T representation is shown like this. So first one, you can see on the left side, that is a star network. So one end of the three elements here connected to the common point O. So here the other three terminals are, so here we say the components are resistors, resistor RA, resistor RB, resistor RC. So the one end of these three resistors connected to the common point O, and the other three ends are shown as terminal A, terminal B, terminal C. So this is a star network. Now, so as I mentioned, this star network can be redrawn as a T network. So that is shown here on the right side. So here see that the first resistor RA is taken as horizontal. Okay. So common point O, and from the same common point resistor RB also drawn horizontally. Then leaving that other end of the RB resistor, leave like that, and then from the common terminal point O, if we draw the third element, that is resistor RC vertically, and its other terminal is C on the down. So this arrangement looks like a T network. Okay, this arrangement looks like a T. That's why it is called as a letter T. That's why it is called as a T network. Now it is also mentioned as 4-terminal network. That means here we see on one side 2 terminals. Okay, on left side terminal A and terminal C. Usually that is an input terminal. We say that input terminals. And the other side, right side, we see the 2 terminals are terminal B and terminal C. So we say it as output terminals. So that is about a star network. Next is delta connection. in delta connection, that means what is this delta connection? In delta connection, end point of each component, end point of, that means if we take a component, that means if we take an element, it may be a resistor or an inductor, that means a coil, or a capacitor. We have two terminals, 2 points. One is start point, another one is end point. Okay. Or we simply say first terminal, second terminal. Whatever may be the component, whatever may be the element, two terminals, 2 points are there. Start point, end point. So here in delta connection, end point of each component, end point, so that means second terminal. Second terminal of each component is connected to the start point of the another component. So that is a delta connection. End point of first one component is connected to the start point of the another component. So that is here also taking three components. Okay. So here look at the second point. It is nothing but simply, we can say delta connection means it is a series connection of three components, three elements. Simply a delta connection, in other way we can also say series connection of three components that are connected to form a triangle. To form a triangle. The name indicates that connection looks like a alphabet delta. Okay. So the name indicates that the connection, so series connection of three elements, okay, connected to form a triangle. That's why this indicates that this connection looks like a alphabet delta. Now the same delta circuit can be redrawn. Then it looks like a symbol pi. It looks like a symbol pi. That is a 4-terminal network. It shows, it looks like, so which is shown here in figure. Okay. Now see, look at that figure. Now, so again this pi network or delta network can also be referred as a pi network. This delta network can also be referred as a delta network. So look at the figure. Delta network. So the left side one, that one shows the delta connection of the three components. Yes or no? See that here three resistors. The first resistor RAB, then RBC, RCA. So delta connection, the end point of each component connected to the start point of the another component. So here the end point of RAB, here this terminal connected to the start point of the resistor RBC. Now the end point of RBC connected to the start point of the resistor RCA. Next, the third one also the same. Now, see that? So that is a delta network, or simply we can say series connection. The three resistors are connected in series to form a triangle. So that's why it is called delta network. Simply. Now, the equivalent of this delta network, the equivalent network of this delta is drawn like this. See that the resistor RAB is drawn horizontally, right? Then from the terminal, okay, it's end point, we have the RBC. So draw that vertically. RBC, draw that vertically. Then from the same point, okay, common point, we have the third resistor RCA. So draw that RCA vertically and the end point of that connected to the start point of the first resistor RAB. So this is how this pi network. So see that here, if we see that there are four terminals 1 and 2, okay, are input terminals. Next, the other side terminals, terminals 3 and terminal 4 are output terminals. So that's why it is called two terminals as input and the other two terminals as output. That's why this terminal is, we can call it as this pi network, four terminal network. Now, the star delta. So far we know what is basically a star network, what is meant by a delta network. Now, transformation. Star to delta transformation and delta to star transformation. That means if a star network is given, how to get its equivalent delta circuit elements and vice versa. So first look here on the left side. See that here the both networks are shown. Delta network is shown and also star network is shown here. Here the delta elements are R1, R2, R1, R2, R3 and the star elements are shown as RA, RB, RC. Now, for a given delta network, how to get its equivalent star network? So, here the delta elements are, clearly we know that R1, R1, R2, R3, delta elements. Now, its equivalent star network is like this. So, the star, let us draw the star network inside of the delta network. Okay. So then we can easily calculate, understand how to remember these expressions, transformation expressions. So as I mentioned, given delta, here first they have given delta network, we have to write its equivalent star network elements. So to write the expression, to get this RA star network resistor in which is in between the delta elements R1 and R3, the expression for this star element RA is given by, so you can look here in the table, the product of the two adjacent delta elements multiplied over sum of three delta elements. To get RA of star network, product of its delta network elements, two elements, that is here R1, R3 over sum of the three delta elements R1, R2 plus R3. So that is how RA we can calculate, RA of the star network. Similarly, the other two elements also. So the element RB, star network RB is given by the product of its adjacent delta circuit elements R1, R2, that is R1, R2. So R1, R2 multiplied over sum of the delta elements again R1 plus R2 plus R3. Next, the third element of the star network RC is given by product of the two elements, delta elements, its adjacent elements R2, R3 over sum of the three delta elements R1 plus R2 plus R3. So that is how, if delta network is given, we can write its equivalent star network elements. And next, similarly, if a star network is given, here in the picture we can see it on the right side. So if a star network with elements RA, RB, RC is given, and how to get its equivalent delta network elements. So here R1, R2, R3. How to get this delta circuit R1, R2, R3 elements. So here first write R1. In order to write this R1, first element of delta, that is given by sum of the product of the each two elements of star network divided by, okay, that means here star sum of the product of the each two elements combination, that means RA, RB RBRC plus RCRA. RARB plus RBRC plus RCRA over its opposite resistance of the star network. Here delta element R1 I want to calculate. So this is star we have. Star is given. We want to write this delta element R1. So what is opposite element to the R1 in opposite element of R1 in star network? The element RC. So in denominator we get element RC. So R1 expression is given by sum of the product of the each two elements in star network over its opposite resistance in star network. So for R1, the opposite element is RC. So that's why it is given by RARB plus RBRC plus RCRA over RC. Next, the next second element of the delta network R2 is given by, the numerator is same. The numerator sum of the product of the each two elements combination in star. Okay, so RARB plus RBRC plus RCRA over. So the opposite element for the R2 in star network is RA. So in denominator we write RA. Next, the expression for R3. So that is given by, again the numerator is same, sum of the product of the each two elements combination over, okay, opposite element to the R3. What is the R3 element opposite element in star? That is RB. So in denominator we write RB. So that is how star to delta transformation and delta to star transformation. That means when a delta circuit is given, how to write its equivalent star network elements. Similarly, when a star network is given, how to write its equivalent delta circuit elements. Okay. Next, derivation for this transformation. Derivation for this delta to star and star to delta transformation. So see that here, initially showing delta network and star network, okay, and taking its transformation equations. So here mentioned, okay, this delta to star and star to delta transformation is quite useful to simplify certain network problems. Okay, that is the useful use of this transformation. Okay, it is quite used to simplify the certain network problems. Okay, then here if three elements meet at a node, then it is a star connection, right? If three elements meet at a node, then the three elements are said to be in a star connection. Whereas if three elements form a closed path, then they are said to be in delta connection. Now here we see the delta network, okay, between the terminals small x, small y, small z with elements RA, RB, RC. Okay, and then star network is shown again between the three terminals, same terminals, small x, small y, small z with the elements R1, R2, R3. Now, converting first on left side, the expressions for delta elements is given in terms of star element values. So we know that how to write the delta elements. So delta element expression is given by sum of the product of the each two elements combination of star over its opposite resistance in star connection. So here for RA, according to this elements here shown here, the both delta and star network shown here, the expression of delta element RA is given by in terms of star elements R1, R2 plus R2, R3 plus R3, R1 over R it is given by R1, right? Then similarly, element RB and element RC expressions also written. Next, similar then if a delta for a given delta network, its equivalent star elements. Okay, so here R1 expression is given by in terms of delta elements. So R1 is given by product of the two adjacent elements of in delta circuit. That means for R1, that is RB/RC. So RB/RC over RA plus RB plus RC. Next, similarly, element R2 and element R3 also given. Next, so next we are entering into the derivation part. How to derive this? We have the equations already, we know. For a given star, how to get equivalent delta elements, similar and vice versa. So now we are going to derive that. So here see that between the terminals X, Y, Z, first consider the star network. So star network, the equivalent resistance between any two terminals. The equivalent resistance between any two terminals here for the star, first between terminals X and Y, between terminals X and Y, its equivalent resistance is given by simply the sum of R1 plus R2, right? So, between terminals X and Y. So, the equivalent resistance is given by simply, okay, it is a common point, right? So, the three terminals are open. So, that's why this is isolated one. So, there is that, that's why the resistance between XY terminals, simply it is given by, okay, simply the sum of R1 plus R2. Okay, we are calculating the resistance. So here, then it is given by simply the sum of R1 plus R2. Next, the resistance, equivalent resistance between terminals Y and Z, it is given by simply R2 plus R3. Simply R2 plus R3. Now, the resistance between X and Z, it is given by R1 plus R3. Now, similarly, coming to the delta network, the equivalent resistance between terminals X and Y first. Between terminals X and Y. Okay, know that these three are in series connection. Okay, so the resistance between X and Y terminals, it is given by, okay, first this RB and RA are in series combination. So this series combination of this RA and RA plus RB in parallel with, that is in parallel with RC, right? In order to get the expression R equivalent between X and Y for the delta circuit, it is given by, okay, between this XY terminals, the series a combination of RB RC is in parallel with the third element RC. That's why it is written as between X and Y, okay, RC into RA plus RB. We know that any two elements connected, any two resistors connected in parallel, then its equivalent resistance is given by product of the two elements divided by sum of the two components. So that's why it is written as RC into RA plus RB over RA plus RB plus RC. Now similarly between X, Y and Z. Between Y and Z, how do we get? So first the other two are in series, okay, that is RB/RC, then that is in parallel with element RA. So that's why it is written as between Y and Z, you can see here. Next, similarly the third one. So that is how the equivalent resistance between any two terminals in the delta circuit, it is taken. In delta circuit, it is taken. Now, Now compare the values. Compare the values. That means in star we have between XY terminals R1 plus R2, okay, which is equivalent to delta equivalent resistance between XY terminals. So compare the values means equate both. So between XY, this is a those two are made equal, and between YZ, between between XZ. So equate the two equivalent resistance of the two circuits. So let us say that equation 1, equation 2, equation 3. Now take equation 3 minus 2. Equation 3 minus 2. So that is given by this here. R3 goes off. So R1 minus R2 equal to R1 minus R2 equal to, then so this becomes here also one term goes off, RA RB gets cancelled. So numerator, okay, equation 3 minus equation 2. So we get RB RC minus RA RC by RA plus RB plus RC. Let us say that equation 4. Equation 4. Now equation 1 and equation 4. Sum of equation 1 and equation 4. Okay. So whatever the equation that is mentioned, equation 4. Now this is added with the other equation, whatever is that is equation 1. We get, so this is equation, okay, 2R1. Okay, we get equation 1, equation 4. Adding them, we get now both sides 2 gets cancelled. So we have the expression for R1 that is given by RB RC by RA plus. So if you see, that is a equation of a star element, okay, in terms of delta elements. Okay, that is how a delta to star transformation is obtained. So now see that similarly we get the remaining two resistance expressions. Okay, similarly we get the, okay, by using the above three equations only. Okay, now we have taken initial equation 3 minus 2, then whatever the resultant equation added 1, equation 4, we have the equation for expression for R1. Similarly, if you take next equation 2 minus equation 1, okay, like that, if then the third case other 2, okay, equation 3 minus equation 1, then you will get the third element equation. So like that we get the other two elements equations. So that is how delta elements are obtained for a given, from a given star network. Next, star to delta. Okay, that means if a star elements are given, how to get the delta, its equivalent delta elements. So here consider the equations of R1, R2, R3. That means equations of star elements, star network elements in terms of delta network elements. So R1 is given by, okay, RB RC by RA plus RB plus RC, and R2 is given by RA RC by RA plus RB plus RC, and R3 is given by RA RB by RA plus RB plus RC. Now see that simply multiply R1 R2, simply multiply R1 R2, okay, we get then, okay, like this, RB RC into RA RC by RA plus RB plus RC whole square. Okay, now see that similarly take R1 R3 multiplication also, we get RA RB RB RC into RA RB by RA plus RB plus RC whole square. So addition of these three, that means R1 R2 R2 R3 multiplication also, then R1 R3. So add the three multiplications. Okay, then see what is the other side, right side. This is a right side expression. Okay. Now, let us simplify. Take LCM, this right side expression. So in denominator we have this RA plus RB plus RC whole square is a common. So in numerator RB RC into RA RC plus RA RC RA, excuse me, RB RC RC RA RB. Now taking common, okay, we can take common in the numerator is RA RB RC. Okay. Then if we take common, then the remaining we get only RA plus RB plus RC in brackets. Now, cancel uh, this RA plus RB RC numerator with the denominator 1. So, RA, sum of the three elements. Okay, so finally at last we have R1 R2 plus R2 R3 plus R1 R3 equal to RA RB RC by R1 plus RA plus RB plus RC. Now, so again, so here it is shown continuation of the next slide, the previous slide. So it is rewritten as on the right side, okay, R1 R2 plus R2 R3 plus R1 R3 equal to, look at the second equation, RA into RB RC by RA plus RB plus RC. Now, from previous knowledge, we know that this RB RC by RA plus RB plus RC is given by R1. So this whole is replaced with R1 R1. So the expression for RA, the expression from this the expression for RA is given by R1 R2 plus R2 R3 plus R3 R1 by R1. So that means the star elements, okay, the star network elements are given in terms of delta, so this is expression for RA. Similarly, we can write for the other two elements, that is RB, okay, and RC also. RB is given by, okay, numerator is same, sum of the product of the each two elements over its opposite element in delta is R2. Okay, that's why in denominator it's R. Then the third element RC is, okay, numerator again the same, sum of the product of the each two elements. Okay, R1 R2 plus R2 R3 plus R3 R1 over R3. So that is a third element expression. So this is how derivation is to get a star to delta and delta to star transformation. So this is all about the derivation of this transformation. Derivation for this transformation. So if we remember the equations, that means if a delta circuit is given, how to write its star network elements by drawing a circuit like this. A star, suppose a delta is given, so then how to write its equivalent star like this. That means we know this star is given by star element, value is given by this element, product of its adjacent delta elements divided by sum of the delta 3 elements. Okay, so if you remember that, then it's easier to write the derivation also. So that is how. And similarly, if a star network is given, how to get its equivalent delta. So let us say this is RA. So this is given by sum of the product of the each two elements combination divided by its opposite element. So if we remember like that, it will be easier to write about the derivation also. Next, a small example based on this. So the problem is calculate the value of three resistances when connected in star. The problem is given, question is calculate the value of the three resistances when connected in star. So here the given circuit is given like this. The given circuit is shown here in the problem. So here see that we have to understand this is a pi network. Pi network means it is a delta, right? So first from the given question we have to understand that. Okay, then we proceed. So here in the question they asked the star connection elements. Calculate the star connection elements. So here if you draw the star network inside of the given delta network, it is easier to calculate, right? So see that. So this star network elements are given by from a given delta. So in numerator product of the two adjacent, its adjacent delta elements divided by sum of the three elements. So like that we have to calculate. So here see that the circuit is drawn, delta given circuit, its equivalent star network is shown with elements RA, RB, RC. So this element RA is given by, okay, this is shown as delta star network elements are shown taken as RA, RB, RC. Okay, okay. You can take any notation, not a problem. So here I am taken as RA, RB, RC. So the element RA is given by product of adjacent, its adjacent delta elements 5 into 10. Okay, 5 into 10 over sum of the three delta elements 5 plus 3 plus 10. So it's given 50 by 18, so it's 2.77 volts. Next, the second element RB. So RB is given by product of the its adjacent two elements in delta. That means 10 into 3. 10 into 3 over, okay, again the same, denominator is same, sum of the three delta elements 5 plus 3 plus 10. So 30 by 18, it gives 1.66 ohms. Next, RC, third element. So product of the its delta network two elements, adjacent elements 5 into 3 over 5 plus 3 plus 10. So 15 over 18, it gives 0.83 ohms. So that is how here delta network is given, its equivalent star network elements are calculated. Okay, that's all for this class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.